Hello students and welcome to my channel SriRam Edutalks. In today's class, we are going to learn a very important topic of class 10th physics, that is formation of different types of images in case of spherical mirrors, that is concave and convex mirrors. So first of all, we are going to talk about concave mirror, and in this we are going to take six possible cases. By six cases, I mean I am going to keep my object at six different positions in front of the mirror. So let us start by taking the first case, in which first of all I am going to keep the object in front of the mirror between P and F, that is between pole of the mirror and the principal focus of the mirror. So first ray that I am going to take is going to be parallel to the principal axis. After reflection from the mirror, it is going to pass through the focus, and the second ray which I am going to take is passing through center of curvature, which is going to retrace its path after getting reflected from the mirror. Now, as you can see, these two rays, which are reflected rays, are diverging, and so they are not going to meet anywhere in front of the mirror. But an image is always formed at a point where at least two rays after reflections meet. So, in this case, I am going to produce these two rays in an imaginary way, and we'll see where they are going to meet. So suppose they are meeting at this point. So here my image is formed, and as it is behind the mirror, so I will write down the position of the mirror as image as behind the mirror. It is virtual and erect. Why? Because it is formed behind the mirror. Erect because it is formed above the principal axis, and it is enlarged. So size wise it has got slightly magnified. Okay, moving on, the second case is, now I am going to move my object even farther from the mirror, that is at F. So first of all, as usual, I will take a ray parallel to the principal axis. After reflection, it is going to pass through the focus, and the second ray again I am going to take passing through C. This also will be retrace its path, and as you can see, these two rays again are not going to meet anywhere in front of the mirror, and they are parallel. So I can say that image here is formed somewhere at infinity. It is going to be real because formed in front of the mirror, and inverted because it is formed below the principal axis, and it's going to be highly magnified. So by highly magnified, we mean that image is going to form somewhere far from the mirror, so it is going to be highly magnified. Moving on, our third case is when the object is between center of curvature and focus. So again we are going to take first ray parallel to the principal axis. After reflection it passes through F, and the second ray we are going to take passing through C. It is going to retrace its path, and if we see here, the object is getting formed beyond C. It is real and inverted again. Real images are always inverted, and again it is magnified. Then moving on, our case 4 is when the object is kept exactly at center of curvature. So this is slightly interesting. First ray parallel to the principal axis. After reflection passes through focus, and the second ray, let's say, passing through focus, after reflection it is going to become parallel to the principal axis. So as you can see, the two reflected rays are meeting again at C only. So the image is formed at C only. It is again real and inverted, and more important is that it is going to be of the same size as the object is. So exactly formed at C and of the same size. Moving on, our fifth case is when we keep the object even farther from the center of curvature. First ray parallel to principal axis. After reflection passing through focus, and second ray passing through focus, getting rebound. So the image here is formed between C and F. It is real and inverted, and it is smaller than the object, so I will write it is diminished. Last of all, when we keep the object anywhere beyond C, that is somewhere very far off from the concave mirror, so in case the object is kept at infinity, that is some unknown far off distance, we know that the light rays coming from a far off object kept at infinity becomes parallel upon reaching the mirror. So they all will become parallel coming from infinity. If we take one more ray at the bottom, so we know that parallel rays passes through focus. So you will see that the object, when kept at infinity, the image is formed at focus, and it is of very small size, or we can say that it is point sized image. So when object is kept at infinity, image is formed exactly at F. It is again real and inverted, and the size is very small, or I can say point sized. So these are the 6 cases of formation of an image in case of a concave mirror. Now let's move on to the convex mirror. So before moving on to convex mirror, let's quickly see a quick summary of all the possible six cases in case of concave mirror. Now, there are two possible cases which we can consider in case of convex mirror. One of the case is when we keep the object anywhere between pole and infinity, that is, we will keep the object anywhere in front of the convex mirror. And in the second case, I am going to move the object at some farther place, that means at infinity. So let's see this case first. So in this case, first ray parallel to the principal axis. After reflection from the mirror, it is going to go in this way, but if I produce it backwards, it is supposed to be passing through focus. So this ray is the actual position of the reflected ray, and when I produced it back, it seems to be passing through F. My second ray in this case would be passing through C. So you have to draw a little carefully. Passing through C. So your ray which passes through C or which appears to pass through C, again retraces its path, but when I have extended it back behind the mirror, here the two rays are appearing to meet and your image will be formed here, that is very close to the focus and of size smaller than the object. So here the image formed is between P and F behind the mirror. It is virtual and erect. Virtual because behind the mirror, and it is diminished, means smaller in size. Okay. Now, if I am going to generalize this particular case, by generalize I mean that if we keep moving the object farther and farther away from the mirror, then the image will become smaller and smaller in size and also will keep on coming closer and closer to the focus. So in case if I keep the object here, the image will move even more closer to the focus and will become even more smaller in size. So that ways, if I keep some object at infinity, then the image will be formed exactly at focus and will be of point-sized nature. So suppose these are the rays coming from infinity, and they will move this way, and if I produce them, they will appear to be passing through focus, or you can say the image will be formed at focus and will be of point-sized nature. So if the object is very far off from the convex mirror, image is formed at focus, virtual and erect, and it will be highly diminished, or I can say point sized. So one thing is sure that In case of convex mirror, the image is always virtual and erect. And second thing is that it is always smaller than the object. Okay. So these are the different cases in case of spherical mirrors. In the next class, we are going to learn about the concave and convex lenses in part 2 of this video. Till then, take care, goodbye, and keep watching SriRam Edutalks. Thank you.